Good morning, I'm Dr. Huang. Today, I'm going to teach you a systematic method to write down the Lewis structures with resonance structures and formal charges. There are a lot of molecules and ions whose Lewis structures are very difficult to write down correctly. Here is a list of them. Well, if you can follow the procedures I'm teaching you here, it will be relatively easy and relatively fast to write down the correct Lewis structures with resonance structures and formal charges for any molecule or any ion. The first step of this method is to obtain a skeleton structure from an instructor. In a skeleton structure, a line or sometimes a dotted line tells us that there is a chemical bond between the two atoms. However, I want to emphasize a line or sometimes a dotted line in a skeleton structure is not always a single bond in the Lewis structure. It can also be a double bond or a triple bond. In a skeleton structure, if there's no line between two atoms, that means there's no chemical bond between them. The second step of this method is to place the valence electrons next to each atom. Each iodine atom has 7 valence electrons. Each chlorine atom also has 7 valence electrons. You can find the number of valence electrons of any atom from a periodic table. This ion has -1 charge. Therefore, it has 1 additional electron. Now let me show you how I place the valence electrons next to each atom. You can start from any atom. Let's start from the central atom. From the skeleton structure, the central atom has 4 neighbors. Remember, you need 1 valence electron for each neighbor. We will take the first valence electron of the central iodine atom and we place it between the central iodine atom and its neighbor on the left. We will take the second valence electron of the central iodine atom and we place it between the central iodine atom and its neighbor at the bottom. We will take the third valence electron of the central iodine atom and we place it between the central iodine atom and the chlorine atom on the right. We will take the fourth valence electron of the central iodine atom and we place it between the central iodine atom and its neighbor on top. Well, we have 3 valence electrons left from the previous step. We will put them into 2 groups. When we place the valence electrons left from the previous step into groups, we always prefer to have groups of 2 electrons unless we have odd number electrons left from the previous step. If we have odd number of valence electrons left from the previous step, we will have 1 group with only 1 electron. All the other groups should have 2 electrons. Well, you may wonder, where do we place them? As long as you don't place them between the central iodine atom and any of its neighbors, it should be fine. Let's place 1 group here, another group here. Well, we are going to do the same for the other atoms. Let's work on the chlorine atom on the left first. From the skeleton structure, it has only 1 neighbor, which is the central iodine atom. Therefore, we will take 1 valence electron of the chlorine atom on the left and we place it between the chlorine atom on the left and its only neighbor. Then we have 6 valence electrons left. Remember, when we place the valence electrons left from the previous step into groups, we always prefer to have groups of 2 electrons unless we have odd number electrons left from the previous step. If we have odd number of valence electrons left from the previous step, we will have 1 group with only 1 electron. All the other groups should have 2 electrons. Since we have 6 electrons left from the previous step, we will have 3 groups of 2 electrons. We will do the same for the other 3 chlorine atoms. Well, you may wonder, Dr. H, where do we place this additional electron? In general, we will place this electron next to the most electroneglected atom of the molecule or ion. In this case, it should be the chlorine atom because chlorine atom is more electronegative than the iodine atom. However, if we place this additional electron next to any chlorine atom, like this one here, we will have too many electrons next to this chlorine atom. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, for a non-central atom, you can only have 8 octet electrons. you cannot have more than 8. Therefore, we have to put this one next to the central atom. If possible, you put electrons into pairs. Therefore, we will put these two together as one pair. Remember, every time when you add an additional electron, you place a -1 formal charge next to that atom. But don't worry, if you forget to add the formal charge at this step, you can add the formal charge to that atom at the very end. Well, the next step is to replace the shared electrons between two atoms with a single stick, which means a single bond in the Lewis structure. The next step is to make sure every atom will have either an octet or an extended octet. Well, let me briefly explain what is an octet. An octet means an atom must have 8 octet electrons. Octet electrons are the electrons we place next to that atom. They include lone pair electrons and shared pair electrons. Well, let's count the octet electrons for each atom. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, when we look at this structure, every atom either have an octet or extended octet. Therefore, this should be a good Lewis structure for this ion. In addition, when we look at this structure, it has only single bonds. Therefore, this one does not have any resonance structure. That means we're done. This should be the Lewis structure you need to present to me during exam or quiz for this ion. A good Lewis structure should only include atomic symbols, lines, dots, and non-zero formal charges.